So in this section, we'll practice working various types of word problems, and I think that these guidelines are pretty good, but there's always guidelines for modeling with equations, and it all boils down to the same problem. You have to be able to understand the relationships among the numerical quantities in the problem, and then understanding those relationships, you have to be able to express those in some sort of algebraic way. And that's the difficulty in word problems, is being able to understand the relationships among the quantities and set up a model using algebra to solve the problem or find out the value of the quantity that you're being asked for. If you start by identifying the variable, and by that I mean saying exactly what number the variable will represent, or saying exactly what quantity the variable represents, you have a better chance of being able to solve the problem. When you're done with the problem, you should always ask yourself if your answer makes sense, and check to make sure that you didn't do any make any algebraic mistakes in getting that answer. But always make sure your answer makes sense with the problem. So let's start this first one, renting a truck. A rental company charges $65 per day and 20 cents per mile for renting a truck. Michael rents a truck for 3 days and his bill comes to $275. How many miles did he drive? What will the variable x represent in this problem? Well, we're asked to find out how many miles Michael drove, and so we should probably start by letting x equal the number of miles Michael drove. Now, you might just want to write down, let x equal miles. That's not descriptive enough. X can't equal miles because we don't know what you mean by that, miles. Is it the number of miles that he drove in one day, or is it the, what do you mean? You have to be very specific and be sure that you say x is a number, so the word number should appear in your statement of describing what x stands for, number of whatever thing you're measuring, in this case miles, that Michael drove. So now that we have identified the variable, we're ready to figure out if there's some sort of other information in the problem that we need to use to get the equation that we want to solve in order to find the answer to the question, how many miles did Michael drive? The equation will have the variable x, so we have to have relationships between x, the number of miles he drove, and other quantities in the problem. Well, some of the quantities in the problem include the daily rental charge for the truck. That's $65 per day. So we jot down on our paper that the cost is $65, and I use the dollar sign because I don't want to just have numbers on the page. I want to know what those numbers are. $65 for 3 days. So that means $65 for 3 days means he is going to have to pay $65 3 times. So one quantity is $65 times 3 is just the cost for renting the truck. But he also has to pay 20 cents for every mile. So we have a mileage cost. The mileage cost is 20 cents. We have to write that in terms of dollars. If you write 20, that's going to mean $20. You have to write that in terms of dollars. So to write 20 cents in terms of dollars, it's $0.20. So 20 cents is $0.20, and that's for how many miles? Well, the expression we're using for the number of miles he drove is the letter x. So for x miles. If it's 20 cents for x miles, and he's going to pay that 20 cents x times. So our cost here for the mileage is 0.2x. Don't need that 0. Now his total bill is given as $275. $275. So that has to equal these two things added together. 65 times 3 plus 0.2 times x. And that is the equation that you can solve for x. Once you have that equation solved, you will know how many miles Michael drove. If you get a number like 2, you probably made a mistake. Its bill is much higher than it would be if he only rode 2 miles. And if you get a number like 8,000, that's probably a mistake too, because I don't think he could drive 8,000 miles and have a bill of only $275. The point I want to make here is that when you're done, make sure you check your answer. Check it for reasonableness as well as mathematical correctness. So verify that you didn't make any mathematical mistakes in the solution of your equation. Now the next problem type is a problem about interest. These usually deal with a pile of money that will be invested at two different rates. So let's see what this problem says. Phyllis invested $12,000, a portion earning a simple interest rate of 4% per year. So it's not compounded, it's just simple interest. And the rest earning a rate of 4% per year. After 1 year, the total interest on these investments was $525. How much money did she invest at each rate? This problem assumes that you know the simple interest formula. The simple interest formula is that the amount of your investment is equal to the principal that you invested times the interest rate plus the amount that you started with. Actually, that's not the formula that I wanted you to know for this. What I really just wanted you to know is this part of the formula right here. That part, P times R, is the interest that you earn on an investment at an annual rate of R with a principal amount of P. So to figure out the amount of interest on an investment, you multiply the amount of the investment, which is called the principal, indicated by P, times the rate of interest at simple interest. That will just be R. So in this problem, the difficulty is that there are two different amounts invested at two different interest rates. So we want to know how much money she invested at each rate. We'll just let the variable represent the amount of money invested at one of the rates. Let's say that X is equal to the amount of money, or we could just use a little dollar sign, dollars, invested at, I'm going to use INV, and I'm going to use that little symbol for at, and let's say that that's the amount of money invested at 4.5% interest. 4.5% interest is 0.045. Oh, this is a little cluttered. Let me get this off of here. Okay. I'll just put it here. I equals PR. Okay, so the amount invested at 4.5% will be X. Now, if she has $12,000 altogether, and she's invested, as we've indicated here, X dollars at 4.5%, so that leaves her 12,000 minus X dollars to be invested at the other interest rate, and that's 4%, so that's 0.04. Now we know the amounts, we know the p-values, okay, and we have the rates, and so that means we can figure out how much interest will be expected at these two for these two investment amounts. So the amount invested at 4.5% is X. So that's if we multiply the rate 0.045 times the principal X, that'll give us the interest for the 4.5% investment. If we add to that the rate 0.04 times the amount of money at 4%, which is 12,000 minus X, that gives us the amount of interest for the 4% investment. Well, this is the amount of interest at the 4.5% investment. This calculation tells us the amount of interest at the 4% investment, and we know that the total amount of interest is $525. So those two things added together must equal 525. And there's the equation. You can solve this equation, and as long as you don't make any algebraic mistakes, you should come up with the correct answer. But from this point on, it's a problem that you should be able to solve. So now let's move to an example of a problem about areas. This is a pretty typical problem type that you'll see quite often. This one deals with the length of a shadow, and if you look at the diagram that's provided, you can, I hope, see a couple of triangles in that figure. We'll talk about that. This problem relies on similar triangles that are same shape but different size. A man is walking away from a lamppost with a light source 6 meters above the ground. The man is 2 meters tall. How long is the man's shadow when he is 10 meters from the lamppost? And as a hint, they say use similar triangles. So let's look at the triangles in this figure. First of all, you see this big triangle, which goes all the way across this bottom on the ground, up the lamppost, and then down over to here. So there's that big triangle, and that big triangle has a hypotenuse, which we don't know the length of, but it has one side here that we know is 6 meters long, and this side down here we know is 10 plus x units long. And the reason we know that is because we have this other triangle in there, which is similar, same shape but different size. Similar, same shape, different size. And I'll sketch that one in red. See this triangle right here, and we have that this side of that triangle is x, but that overlays on the blue triangle, so that x part on the red triangle is also x part on the blue triangle, and that's why this is 10 plus x. The man is 2 meters tall, so there's 2 meters right there, and that red triangle we also don't know what the hypotenuse is. The question is, how long is the man's shadow when he is 10 meters from the lamppost? So you need the 10 so you can figure out the length of the long blue triangle as 10 plus x. So the idea is to find x. Well, we know that the blue triangle and the red triangle are same shape, different size, and so corresponding sides are proportional. So that means if we look at the side that's 6 meters long and compare that to the side that it corresponds to in the other triangle that's 2 meters long, that ratio is the same as two other corresponding sides that we know. Well, we know the side that's 10 plus x units long, and that corresponds to the side that is x units long. So you see now we have an equation. It's an equation that involves rational expressions, but it's actually quite simple because if I were you, what I would do first is rewrite that as 3. So the equation becomes 3 equals 10 plus x over x. And I think it's really pretty easy to solve this equation. As a hint, I'll just tell you multiply both sides by x, and then you have a 9th grade algebra problem. So you can solve that problem. The next problem type is mixtures and concentrations problem type. So these are typically involving two quantities that you want to mix together to make a third quantity, and so you need to know how much to mix of one or the other to make your concentration what you want it to be in the mixture. So what quantity of a 60% solution must be mixed with a 30% solution to produce 300 milliliters of a 50% solution? It doesn't sound like you have very much information, but you actually have quite a bit of information in this problem. Let me show you what the information is that we have and how this problem is not really that difficult. First, we'll draw little pictures. I think you should always draw little pictures with these problems. Get out of your head, get onto your paper here. So this little picture will represent a beaker that contains the 60% solution. So I'm going to put 60%, but I don't know how much is in that beaker. Some unknown number of milliliters is in that beaker. I don't know how much. Then I have to mix that with a 30% solution. So I'm going to add to that something from another beaker that is half as concentrated, 30%. It's 30% concentrated. And again, I don't know how much of that I I have. So I'm going to mix some of this together, and I'm going to produce a mixture now, which has a concentration of 50%, and that makes sense. I'm starting with 60% and I'm diluting it with a 30% solution, so I should expect the result to be something less than 60%. But this time, I know how much solution is in the beaker. This has 300 milliliters of solution in it, half of which is acid. So in that beaker with 300 milliliters of solution, I'm going to have half acid. So 150 milliliters will be acid, and the rest will be whatever the acid is dissolved in, probably water. So there's my key idea. My key idea is that I've got to end up with 300 milliliters of solution, and I don't know how much of either of these I'm using. So suppose, since we want to find the quantity of 60% solution, suppose we let that be X. So X is the number of milliliters of 60% acid solution that we need. 60% solution that we need. Well, if I'm going to end up with 300, that means that for the other solution, it must be 300 minus X. There must be 300 minus X. That should give me the number of milliliters of 30% solution. And that makes sense, because if you add those two expressions together, X plus 300 minus X, so imagine that you're pouring the X milliliters into a beaker, and you're pouring the 300 minus X milliliters into that same beaker. The two X's add up to 0 because one has a minus sign, so you end up with 300 milliliters, which is what you're supposed to have. So these expressions give me the right relationship between the 60% and 30% solutions. So now it's just like previous problems. It's sort of a rate times concentration times amount equals what you have. So in other words, if I have X milliliters of solution and 60% of that is acid, then the amount of acid in that solution is 0.6 X. 60% of X is acid in that solution. The other one, the 30% solution, is 30%, 0.3 of the 300 minus X milliliters. That part is acid. This is the part that's acid in the 60% solution. This expression represents the part that's acid in the 30% solution. Well, how much acid is there in a solution that's 50% acid if there's 300 milliliters in the jar? Well, 50% of 300 is 150. So that means that at the end, I'm going to end up with 150 milliliters of acid. So these three things represent how much acid there is. These three expressions, 0.6x, 0.3 times 300 minus x, and the number 150, represent how much acid there is in this beaker when I'm done. So clearly, if I add these two expressions together on the left-hand side, they should add up to 150. I'm assuming I don't spill any acid on the counter. Well, there's your equation. You should again be able to solve that equation. And then once you do, you should know how much of the 60% solution you need to add. Next kind of problem is problems that have to do with working and doing jobs, and they're called combined rate problems, but I guess your textbook doesn't really quantify them or name them that way. So essentially, two people are doing a job at the same time, and you want to know how long it takes them if they work. How long will it take them if they work together? And in this situation, our people are Candy and Tim, and they share a paper route. I want to get my red pencil here. And Candy takes 70 minutes to deliver all the papers, and Tim takes 80 minutes to deliver all the papers. So what we want to know is, how long does it take them if they work together? It should be some number, I suppose, less than 80. So let's see and it might even be less than 70. Candy should be able to work faster if Tim's working with her. So if we want to know how long it takes them when they work together, that means we should let x equal the time. And this is all in minutes. We have to make sure we remember that, time in minutes, to do the job together. Now, it occurs to me that this is going to be too long. So what I would like to do is just stop it here, and we'll talk about this problem and also the problem which has to do with distance, speed, and time. We'll talk about those two problems in class. I think you have enough now with the first four to keep you busy on this handout for the weekend. Thank you.